In this video, we are going to look at a Lagrange multipliers example where we find the max and minimum values of a function. So the example says to find the maximum and minimum values of f of x comma y equals x squared plus y squared minus 2y given 4x squared plus y squared is equal to 9. So when a question asks us to find the max or the min values, and it says that specific word values, it's referring to the outputs of the function. So I notice that we have this function f that we want to maximize and minimize, and we are given a constraint that is this 4x squared plus y squared equals 9. So I can rearrange this as 4x squared plus y squared minus 9 equals 0. And once I have everything on one side so that the other side is equal to 0, the left-hand side of this equation is what we call the function g. So now we are ready to construct the Lagrangian function. So we've been calling this L, and there's two variables in our functions here, so it'll be L of x comma y. And we start off by writing f, x squared plus y squared minus 2y, and then we do minus lambda times g, which is 4x squared plus y squared minus 9. So remember, the overall form of this is f, and then you have minus lambda times g. So next we find the critical points. So we are going to need to take some partial derivatives of this. So let's take the partial with respect to x and set that equal to 0, and the partial with respect to y and set that equal to 0. So before I take these partials, let's simplify our Lagrangian function a little bit. Let's distribute the minus lambda into g, and that'll give us minus 4 lambda x squared minus lambda y squared plus 9 lambda. So now if I take the partials, the partial with respect to x is going to give me 2x. The next two terms are going to both have 0 for their partial. And then this other x squared term with a lambda is going to appear still. That partial is going to be minus a lambda x. And that's the partial with respect to x. And I set that equal to 0. For the partial with respect to y, from the first three terms, we will end up with 2y minus 2. And then from the last three terms, it's only the minus lambda y squared that's going to give me a non-zero partial derivative. So for that one, I will end up with minus 2 lambda y. And I set this equal to 0 because I'm trying to find the critical points. So I'm going to call this top equation equation 1, and the second equation equation 2. And there's three unknowns here. There's x, there's y, and there's lambda. So I'll need a third equation, which is my constraint. And that was 4x squared plus y squared equals 9. So now I have to solve the system. So if I look at my first equation, the system of equations part is typically where there's a few different ways that we could approach this. But if I look at my first equation right here, I notice that I can factor out a 2 and an x. And that'll leave me with 1 from the first term and minus 4 lambda from the second term. And that's equal to 0. One really important cautionary thing is we don't want to divide and cancel by x. If I were to divide both sides of this equation by x, it seemingly would have canceled away, but we've talked about that before. That's kind of a no-no from algebra, because this causes us to lose a solution. And we might be losing where the max or the min happens if we were to do that. We definitely don't want to do that. Okay, so instead, we want to factor like we did. And this gives us 2 two possibilities. From the first factor, I get that x could be 0. And from the second factor, there's 1 minus 4 lambda. Well, that would be equal to 0 when lambda equals 1/4. So now we have to consider these two possibilities. So first, let's do when x equals 0. And if x equals 0, the simplest thing I could do is plug this into the third equation. So let's take this and plug into the third equation. That'll give us 4 times 0 squared, because x is 0, plus y squared equals 9. So we'll get y squared equals 9, or square rooting, we get y equals plus or minus 3. So overall, here we're getting x is 0, and y could be either positive or negative 3. We're getting two possible candidates, two possible critical points. And notice that in this case where x equals 0, we actually didn't even need that second equation at all. If we had taken these y values like 3 and negative 3 and plugged them into that second equation, it would let us find what lambda is. But ultimately, we didn't need what lambda was to find my critical points in this case. Okay, so that's nice. It's a little bit less work. Okay, so now let's look at the other case where lambda equals 1/4. So let's plug, because we know what lambda is, let's plug it into the other equation that has lambda, which is 2. Let's plug this into equation 2, and that will give us 2y minus 2 minus 2 times lambda, so 1/4, times y equals 0. And if we simplify this, we get 2y minus, this is going to be 1/2 y, this last term. So that simplifies to 3/2 y. And if I move the minus 2 over to the other side, this equals positive 2. And I can rearrange this to get y equals 2 times 2/3, which is 4/3. All right, so now I know my y value, and I can plug that into the third equation to find x. So let's plug this into the third equation. So we'll get 4x squared plus y squared, 4/3 squared, equals 9. Okay, so simplifying this, we get 4x squared equals 9 minus 4/3 squared, which is going to be 16/9. And overall, if I get a common denominator with a 9 and the 16/9, and I subtract, we'll end up getting 65/9. All right, so now if I divide by 4, we get x squared equals 65/36. And square rooting both sides, we get x equals plus or minus. On the top, I get square root of 65. On the bottom, I'll get square root of 36, which is just 6. So here we're getting two possible points. The x coordinate can be either positive or negative, root 65/6. And the y value we got was 4/3 in this case. All right, so overall from Lagrange, we're getting a few different points here. So there's something that I want to make a note of, which I've talked about before, but we just haven't seen an example like this. When we do Lagrange and it gives us more than one point, then what we do is we plug all of the points we got into our objective function, f. And the largest output that we get is our max value, and the smallest output is our min value. We are going to assume that that's the case. So let's go ahead and take all of these points, plug them into f to see what's the biggest output and what's the smallest output. All right, so here was our function as a reminder, and here are the candidates that we got that we need to now plug in. All right, so let's plug in 0, 3. And if I were to do that, we get 0 squared plus 3 squared minus 2 times 3. So this becomes 9 minus 6, which is 3. And if I plug in 0, negative 3, it's going to give me something slightly different because this minus 2y term is now going to have the opposite sign. So plugging in, we get 0 squared plus, this time negative 3 squared, and then minus 2 times negative 3. So this time we get 9 plus 6, which is 15. Okay, so a bigger number that time. And then we got to plug in the plus or minus root 65 divided by 6, and then for x, and then 4/3 for y. One thing that's going to reduce my work there is I noticed that there's the y value for those 2 points is the same, but the x could be either positive or negative. And I noticed that when I square the x value, we'll end up getting the same thing, no matter which of those two I plug in, the positive root or the negative root. So let's just do both of them at the same time. F of plus or minus root 65 over 6 for the x, and then 4/3 for the y. If I plug those in, I'll get plus or minus root 65 over 6 being squared for x squared, and then plus 4/3 squared for y squared, and then minus 2 times 4/3. So if we simplify, squaring the first term, we get 65 over 36 plus 16 over 9 minus 8/3. So now we need to get a common denominator. 65 over 36 plus the next fraction I should multiply on the top and the bottom by 4. That gives me 64 over 36. The next fraction I got to multiply on the top and the bottom by 12, and that'll give me 96 over 36. And now working this out, we end up getting 33 over 36, which simplifies. I could divide the top and the bottom by 3 to get 11 over 12. Alrighty, so we've plugged in all of our critical points, and the largest value that we were getting out was 15. That was our biggest output. So this is our max. And the smallest output that we were getting was the 11 over 12. So that is our min. So we are ready to write down our conclusion. It was asking for the values. So the max value is asking for that biggest possible output, which is 15. This question technically didn't ask us to find the points where we got that max value. It just asked for the value itself. So we could leave it like this. If we needed to write down the points where it happened, we would write something like, oh, it occurs at 0, negative 3. So similarly for the min value is 11 over 12, which is our answer. That's what it wanted. And if we needed to write down where it occurs at 2 points, plus or minus root 65 over 6, comma, 4/3, and we would write something like that. So in the next video, we will do another Lagrange example where we have to find a max and a min. So we'll get multiple critical points like this. And we'll do casework just like we did in this example. But now there's going to be 3 variables as opposed to 2.